Hi guys, Frankie V from FrozenSand here with another episode of Working with Power Tools, where we're going to begin with a bit of an announcement that I'll be moving all my video blog stuff relating to Urban Terror HD over to our official channel now that I got a good sense of what's what and how things are working. And I'll post the URL in the comment section, so if you wish to continue following along with the behind the scenes going ons, by all means head on over there and subscribe, and we'll continue to do our updates from there as far as new content and information that should be conveyed to the community as a whole, as well as maybe to upsize things a bit. Who knows? But it's now time to get a little bit more serious and start putting things together now that we've more or less, well, at least I've become a little bit more comfortable with working with Unreal 4 engine. So that's to say that a lot of what we would be doing, I guess a word for it would be called nesting, as in figuring out all the buttons and bells and whistles. What's the best way to proceed forward as far as the overall design pathway goes. We've already established the fact that the ideal would be to do a one-to-one conversion from the id Tech 3 engine over to Unreal 4, and what would have been even more ideal is if we could have followed through on the original licensing of the id Tech 3 engine, so we could have made the improvements that needed to be done to the FS Tech 1 engine design. But unfortunately, that was not to be. So, it is our intent and intention to make sure that the game is playable on all platforms, and it will be around for the next 15 years, as well as to make substantial improvements in performance as to the needs for competitive game playing, which is obviously a hallmark of Urban Terror HD, of Urban Terror in general, as it has been for the past 15 years. So we definitely want to maintain the classic gameplay that has become Unreal Tournament, or Unreal Tournament, has become Urban Terror. And there's nothing really that we've discovered over, or certainly I've discovered over the years of being involved, that that there's anything inherently wrong with the game itself as far as art and content and playability and what have you. And it certainly could survive another 15 years just the way it is, except for the fact that technology has a habit of making things obsolete. A good example of that is I used to have a bin full of 3.5-inch discs with some really old classical games, some of them not even as old as Urban Terror, that can no longer install or load or even run on today's current operating system or platform. So that's the kind of thing that we're trying to avoid. If at some point it would be kind of disastrous if all of a sudden some third-party hardware manufacturer or Microsoft decides to exclude a major component of functionality of that is required by the game. Then the whole thing will just fall apart like a stack of cards almost overnight. And as well as we want to make sure that, of course, that the game is playable by anyone on lower end hardware specifications, with no more than an uncostly type of upgrade, maybe to a newer video card or what have you. But that's still to be seen. The expectation is that Urban Terror HD should be able to perform, let's say, significantly better than id Tech 3 on newer hardware or even on older hardware. So I would say that anything within the last 6 years should be able to outperform in HD than the same version that they're playing on id Tech 3 on their poor little pooter, trying to keep up with the higher frame rates. So obviously this was proved out through the the FS Tech alpha testing, HD to alpha testing a few years back, that there was a significant improvement in performance, even with a slight bump from going up to as high as OpenGL version 2, which was it version 2? Yeah, I'm pretty sure it was version 2, which only used a little bit and is like 2004 technology. So obviously there's going to be a much more huge jump in performance moving to the Unreal 4 engine. So that's the vision. The vision is to use the current iteration under Intake 3 as the blueprint as towards moving towards HD, and try to keep as much of the gameplay, everything the same. As you can see, you probably recognize this map here. We'll be getting into this in a short here. This is going to be a little bit of a long episode because I'm going to try to cover a fair amount of information with the move over. As I said, it's time to get a little bit more serious about things, about intentions, and the ideal is to be able to take a map that, in this case, Casa, that is a classic map and represented by community gameplay as far as competitive game goes. It's a popular capture the flag map as well as Team Survivor and what have you. So we want to maintain that connection between old and new. And personally, I see nothing wrong whatsoever with the current art and content that is representative of urban terror in the form of some of the maps. A lot of them would hold up quite nicely today, even on inside of AAA games as far as the art content goes. And except for maybe a quick conversion over to a better lighting system, that's only the real improvement that is needed. And this is the idea behind Casa, is to obviously is to be able to take a map that and maintain that continuity between old and new. Which is what we always have and intended. There's, as I said, there's nothing wrong with how things are now. So let's keep it the same as much as possible. And it obviously took a bit of testing, a little bit of observation, discovery, to figure out, can we maintain that pathway? And the short answer to that, of course, is yes, definitely. There is nothing and there is nothing about the Unreal 4 engine that adds a performance hit just on at idle, so to speak. So it can run on an iPad, it can run on a web browser, it can run on on an Apple or a Mac, just about as equally as fast, or as have at least as high of a performance curve as any other, like a PC, for example. It can run on a console, and it's just a screamer of an engine as compared to the Intake 3. So the assumption right now, until we actually get into some actual practical game testing, is to jump on the engine a bit to see if it'll break. What is the expected performance curve? And I've recently done a test to kind of prove that point out, that it's a map like Casa is, I mean, it's nothing. We're going to get into it in just a minute here, but there is it's almost like playing in an environment that's not really there as far as performance goes, and the whatever video card you have, it'll just kind of say, oh well, what the heck is that? So I'll post a link to the performance envelope test that I performed just recently, and it does obviously there's going to be an advantage for players who are serious gamers, like they're serious competitors. It's Unreal 4 is a serious engine, and that the problems of things like that have always been a problem, like ping-induced misses, is no longer a problem. I'm not a network guy, and I don't really understand what they're talking about as far as network gaming play goes. But the word used that I've heard was that the person that you're shooting at is going to be the person you're going to be shooting at. They're there, regardless of what your ping rate is. So even though you might have to suffer through the latency of network play, that person that's in your gun sight's not going to all of a sudden disappear on you. So that's that's a great equalizer as far as competitive gaming goes, and I'm looking really forward to seeing just how that translates into actual gameplay in a practical on a practical server, so to speak. So anyways, let's get on to the point of this all. The original attempt, as you can see at Casa, the idea behind it is keep it classic status. How you see it in 4.2 is how we want it to be presented in Urban Terror HD, and everything being the same. The jumps will be the same, the buildings will be the same, the blocking will be the same. So there'll be a one-to-one correspondence that if you were playing, ideally, if you're playing in 4.3, you're playing on Casa, and somebody else slips this in behind you. The only thing you'll see noticeable difference is, of course, is some of the quality of the lighting, of course. The materials, there'll be some improvements. We'll get into that in just a moment. But more or less, there'll be no difference. So this gives us the ability to create kind of an easement, a jumping point in from the old into the new without hopefully ripping the fabric, so to speak. And I think it's pretty. It's obtainable. So okay, so one of the things I wanted to cover was, of course, is how to do a .map conversion from GDK into Urban Terror HD. Unfortunately, it's a finicky process that you can't really sit down and say, okay, here's how to do it by the numbers. You do this, 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 and this is your result. It's there's too many variables, too many different types of applications that are being used to actually do a rather concise tutorial on a how-to. There goes the local air taxi, and it's it'd be too difficult to break it all down into individuals. So I'm just going to do this in a lecture form. I'm assuming that anybody who's going to do a map conversion knows how to do mapping in the first place, so they have at least some familiarity with what they're working with, much better than I could probably do on a one-to-one basis. So using Casa as the example, it was just simply to get it into this point was simply to export it as an OBJ, and that's where things kind of go off track a bit, because there's not really one OBJ format to rule them all. There's various different types that all have some kind of prefix put onto it that says, okay, this is GDK OBJ, which means that the export is not necessarily the same as going to be the import. So to have a one-to-one import of something out of GDK into Urban Terror into 3ds Max, I would have to go out and find the exact formatted OBJ importer to bring it in as to being intact, let's say, maintaining the continuity of the asset out of GDK into 3ds Max. Unfortunately, that's a fail, because what tends to happen in this case, in this type of configuration, going from GDK into 3ds Max, is the UV mapping flips, or it's maybe the normals get flipped. So it gets flipped and it gets mirrored. So that creates the need for a patch type fix. So in this case, you have to first export the map file. The OBJ does not maintain the materials pathways, unfortunately, so you don't automatically get what's in GDK and then import it into 3ds Max, and all of a sudden, boom, there's your materials and textures. So now you have another process that you have to go through, and that is to reestablish, of course, your material links as to identifying the different materials that are applied to the different surfaces. In GDK, you would want to export it by material. What surfaces has what kind of material applied to it, which creates this. Let's see. I don't know if I have all the wire. Yeah, there is some difference in the wire and color coding. So each of these objects are brought in based on its material type. So you have a roof over here, 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 Anything with metal, you might have metal over here, here. So this allows you to, and then the name of the material is included as the object name. So this allows you to actually go in and reestablish your material chain as being connected to a particular object. So it takes a fair, it takes a fair amount of work. The whole process from start to finish, once you get the hang of it, you've done it a couple of times. It takes only a couple of hours or two. Well, in the case of Casa, it's a fairly large map, so it took about to get to this stage where you see it right now, ready to be exported as a block, and took about 4 hours. So that really, the really time-consuming part, of course, is doing the stuff manual. In which case, we bring up I would have to bring up the editor. I would bring up a Windows Explorer, and then just do a search for the material, drag and drop the material onto it, and then I would just select the eyedropper here, select that, and then rename the material to the name of the object. So this way I create a connectivity between the material and the object itself. So once we actually start breaking things down, I'll do a bit of a lecture on that in just a minute here. Once we start breaking things down into blocks, then it becomes a lot more easier to be able to maintain a direct connection in Unreal 4 as to the material that is connected to what object. So that way you're not, once you start breaking things down, it maintains the material ID. So you're not having this problem of every time you import a new object, you're getting duplications of the different types of materials. So once we establish this, we've more or less locked our material into the object itself, and we're good to go as far as moving forward. Now, first thing you want to do when we're going to jump over to that is to export everything as a single block, one big fracking file. So we just kind of select all, and we would export that to FBX export selected, just in case. And in this case, I exported everything else as Casa block. I won't do go through the process. It's just easier just to kind of stay on lecture here. But I would export the entire information as a Casa block, with, now that I've established all my material connections, and then that those material information would be included in this FBX file, and everything's set up for us to bring that over into Unreal 4. Now, that's the suggestion I always consistently make, is when you're working on this type of idea, building your environments inside of 3ds Max, is to first get it out and over into Unreal 4 as soon as possible. The purpose here is to first create a strong connection between 3ds Max and what we're editing in there versus what is ultimately imported into Unreal 4. So Casa being a conversion, it's more or less completed as far as in design, but in some situations these could be just box objects. So for example, if I go to the top view, I can go create standard box and create just as easy a proxy in the middle of the courtyard, and we'll move that over to and we'll do a little bit of a rotate. Oops, not that way. We'll do a bit of a rotate here and move into the center of our marketplace. And of course, this is of course the 1%ers taken over. So this is condo. This is a CONDO. So we've created a box primitive that represents a volume of space that's going to be later on be replaced by a thing called condo. So we can build various different components within this environment in place, and then we can export it out over into Unreal 4, and then make design decisions once we can see it in there. What can we pull off of where as an instance copy, so we can keep the performance curve high and not have a lot of duplication involved. So I think we've more or less covered everything here. Okay, the one thing we haven't done so far, of course, is to create collision meshes. Now, once again, this follows the idea of lecture form pathology that we can always create collisions later once we get everything up and running in Unreal 4, just for the purpose of evaluation. Now, I think we more or less covered all the key points of what we need to cover in this application. Now, this would probably vary from edit application to edit application. I don't know how this would behave in Blender. Blender uses a different OBJ importer once again, so who knows, if you import into Blender, it might turn out that it will import perfectly, and then if you reestablish your material chain in Blender, then you're good to go. So once I've established my material chain, of course, is to correct the materials itself, and that is to consolidate the materials into a single folder. And 3ds Max has a feature for that called the resource collector, so we can collect anything that is attached to the scene as far as materials goes, wherever they may be in individual, Lord knows what directories, and consolidate them underneath one directory. That would then can go in and use any kind of, wow, we can go in and use any kind of 3D application and go in and just rotate and mirror and flip the materials, and boom, we have instant conformity of our materials as to our environment. We can actually do that as a pre-process, but if we know where our materials are, if you already know that all your textures and materials are in what, wow, what the heck is that? I don't know what the heck. Okay, so I'm back on topic here. If you already know what your materials are and you already have them consolidated into a single folder, just go in and using 3ds Max, and you can go in and rotate, use I can't remember there's tons of them out there, but I just use a simple application 3D viewer to go in and rotate and mirror the material and texture so they fit properly. Some of them I did miss. We're going to see that once we get over into the bread and butter stuff. But for the most part, except for a few details, Casa is done. As you can see here, it took a couple hours, 4 hours. Missing models. It only pulls out the brushes, so we've got some model replacement to do. And let's go ahead and see what the results are once we import them into and connect our materials up to properly in Unreal 4. Right away you can see that we have a bit of a material issue here that it's simple enough to fix. We're not going to worry about that. But as I mentioned, the idea here is to maintain the quality and look of Casa in HD as a classic map. And I think by just kind of moving around a bit, you can see that except for maybe the improvement in the lighting solution, that overall that it's Casa. It's there is a one-to-one flavor to it. This is how it's probably ultimately going to look by the time it's delivered, except for, of course, for the material, some of the material misalignments, fine-tuning. I'd like to show you something else too here that I kind of overlooked as to how come this is going to be like one of the top performing performance maps in HD, based on the proof of concept. Once again, check out the link, see how much we can go, how far the deep end is before you start getting into serious problems. We're talking ultimately being able to have a playable area of about 17 megabytes in size, all viewable at once with absolutely no performance enhancements. Where in this case, if I go over to my poly counter, you can see that Casa incomplete is 24K. If I decrease it, that's the poly count. There goes that truck again. If I decrease that to use polycounts instead, that's 12K. That's nothing. That this will play as long as we can get the game proper. This will play on an iPad. It will play on a portable. It will give you the same probably kind of speeds that you expect, and well, I mean, it's nothing. So performance-wise, we can still make even more improvements. So well, this brings us back over to our Casa version. As I mentioned, this is going to be built up again, and we can look down. Okay, let's talk a little bit about how to make life easier for as far as being able to do a conversion. If this is something that you're looking into, I'm trying to cover a lot of bases here. So let's create a test folder. Actually, this is going to be the actual production asset layout. So okay, let's say for example I have my Casa block. You see, kind of gotta remember back a bit how I put everything out as one big huge block. But let's look at some of the import features that we need to pay attention to here to be able to pull this off, so that you know, we can quickly get things in and up and running. And the one thing that you need to be observant about, of course, is generate light maps, UVWs. This is what really caused a hitch at the beginning, because well, you had to go around and manually light map, create a second UV mapping channel for the light maps, and it was it's a time-intensive process that is not really necessary. So in this case, when we do an import, the import option that you probably want for the purpose of bringing in one big block is to generate UV mappings for the various different items that you bring in. Now, what you can do as an option is you can bind everything as a single mesh. This will it becomes a little bit more difficult to start breaking things out a bit. I prefer to bring them in as single objects. That way I can kind of drag and drop. So in this case, I'm just going to bring in the rooftops here. You know, I just wanted to fill some holes in, so that's what I'm doing. Import materials and import textures. As long as you create that proper material ID, this will make things easier for you to identify what material belongs with what. And we'll be getting into material discussions in just a minute here. So we'll go back to Unreal, and we'll go ahead and we'll do an import, and that brings us down our rooftops, and you can see that we have a default material settings that we didn't name. And if I kind of drag that and drop that out, you can see that it's in there somewhere. It's actually below the Z-plane by the looks of it. Where did it go? Gotta kind of look around, see if we can find it. Nope. Okay, so what we want to do is, since it was what's called edit in place, in other words, we want to have a one-to-one origin of 000 correspondence between whatever we make in 3ds Max will be reflected in the same locations within Unreal 4. So in this case, what we just reset it back to 000. So now if we go up top there, we can see that there's our rooftop. Let's do this a little bit more serious wise, because I already did that. So we're bringing our rooftop. You can see there it is. It's out of alignment. We just hit the reset, and exactly where it was made in 3ds Max is where it snaps into place. Then we can go ahead if we want, and we can change the material. Okay, let's find a material, any material. Okay, we'll drop that on there, a little wood tiling, and our rooftop is done. But we kind of need to do one more step here, and that is there's a couple of ways of doing this, and we need to establish some sort of collision blocking so that when we say, for example, we hit the play button, we don't fall through the object. So I think I just killed my by adding, I think I killed my FPS here. Okay, let's take a look. Yeah, I just killed that my expected FPS. For some reason or another, there's a bug in it, and when you bring in a new object into the environment, it kind of trashes the light mapping. It's not quite set up to be the most efficient at the moment. Okay, so let's try to see if I can. Nope. Okay, so we have kind of a buggy thing going on here for some reason or another that's kind of messing up my frame rates. I'm not going to start over again, so we're just going to have to kind of trudge through it. Now there's I don't know where it is or where it's being caused, but every time you put in a new object and you do a build or whatever, then your frame rates kind of tank. So that's something that needs to be fixed. I never noticed that before. But to kind of move forward on with the rooftop I have in place. I got to kind of find that and select that, bring that open, and I need to change you can change the map resolution by selecting it, as well as collision complexity. So if we use complex collision as simple, then we can go back, and now when we hopefully we don't come on, clear up. Okay, we're on the roof. Okay, this is going to be a little bit more difficult to fix, but I'm going to fix this. I'm going to fix it. Okay, so let's make sure we have cover screen. Okay, let's go to our engine, and we're going to clear that out. We're not going to save. Don't save it. And I'm going to go see if I can get back to... sorry about this, guys. Kind of slows things down. Okay, and I'm using the shooter framework, by the way. It's a sample file available through Epic that is completely playable as far as gameplay goes. I'm still waiting for Barbie to kind of finish off his thing, but I don't want to see anything from him until he's satisfied at his working away as to expectations, because it's always a pain in the butt to have to kind of deal with that kind of patchwork type of workflow. So I'd like to be able to have something in hand that that I can actually demonstrate to you, not something that I'm going to kind of have to hide behind the scenes. Okay, so I have to change this complexity, and we can kind of sort of run around the rooftops here. And we're not following through it, and we did the same thing to the rest of the ground planes and so forth. Now, to do this all in one chunk, it's actually quite simple. If we go to our filters here and we say, okay, well, all we want is the static mesh. It pops up all our static meshes as part of our block build. Remember, this is for the intent and purpose of testing until we can start doing breakdowns, and I'll discuss a little bit about that in just a second here. Okay, so asset actions. Now, asset actions allow you to use a property matrix, which is any value that can be changed as a multiple value between various different selected objects can be made. And if we hit that, you can see that every object that is currently in our scene has been selected, and then it's just a matter of going up to body setup, and then down here you can set your collision complexity to use complex collision as simple. Light map resolutions, you can also change the map resolutions, as well as what channel the light map is located on. Now, if you use the self-generated import, then that would obviously place your light map on channel 1, but you can have more than different types of light channels if you wish. If you want to make your own, you can then place it on, say, channel 2 or whatever. So it's completely flexible in that way. So to get to this point, took about 4 hours, if less. I don't know. There was some coffee drinking and some Netflix watching involved. But the result is, of course, is a playable environment for the purpose of testing. And let's just set things up here a bit more to taste. And FPS. And as I discussed previously, the FPS indicator over there is, well, running around in the Pi in the editor is... it's not a very realistic number. There's a bunch of other stuff going in the background, so this thing absolutely nails. I mean, I should uncap that and see how high we can go. But for the purpose of testing the environment here, to get a sense that this is Casa, we can use the shooter game to kind of get that sense until our physics system is completed. And we can start doing some wall jumping. We can kind of jump into the wall. We can't jump off of the wall. But you can see that So this looks exactly more, I would think anyways, exactly how it should look. It looks like in 4.2, soon to be 4.5. Okay. So, what are some of the other key features that I plan on doing as far as tuning and further development? Let's see if I can get back over to. Okay, the next step from here. This is just to kind of get out right now how to do that conversion step. We're going to go into a little bit more detail. Granted, there are going to be questions about relating to specific needs and requirements. So by all means, head over to our forums. I'll post a link once again in the comment section as to our mapping section, so you can kind of ask these types of questions of how to get your map converted, and we'll do our best to try to help you, particularly some of the classic maps that should be make its way sometime over to HD. It's not really that difficult. A difficult point from this stage really is to start doing breakdowns, break things down into blocks, because as far as performance goes, obviously the amount of triangles and polygons that we have currently in the scene is nothing. I mean, it's a joke. But we can actually increase, even further fine-tune the performance envelope of this by breaking things down into calling blocks. Now, calling, if you don't know, is when if the engine doesn't see an object in the background behind another object, it doesn't render it. But since we have everything broken down by material types, that would mean that anytime we see a given object in a section, then anything connected to that section is going to be rendered. So let's say, for example, we're in this area down here. If we select and we see this building here, you can see that there goes the duck. That if we see this building here, you can see a whole bunch of other stuff in the background starts to light up too as well. So they're in the background and it would be rendered as compared to what we see visually. Now, the reason we want to call it is so we can keep the draw cost down to mega low. The lower we can keep it, the faster we're going to get the performance curve out of it, and the lower end machines are just going to have a good time. They're going to have some serious playability factors. Now, moving on, kind of lost my train of thought of how we're going to be breaking this stuff up. So once, not finished in here. So the idea behind it, of course, is to start breaking things down by blocks, and that's simply a simple process by just selecting everything, and we can put an instant edit poly modifier onto the stack. We can do by selection, and then we can go in and weed out subblocks. Oops, let's select everything. We can start weeding out subblocks. Say we want this to be a block, and then we can do a detach, and then we can do an invert selection. No, get out of this. That should keep our bulk selection. We can do an invert selection, and then we just can go ahead and put that on a layer. Bring the layer over here, and we'll call this, for example, create new layer. Building 1. So now we can export this as a complete buildings selection, maintain our material connection to it. Let's see if I can isolate that. Okay, so there's our section. This could even finally tune down even more. So we just get this building in here. That's building 1. And then we'll create a UCX collision mesh for that. And that as far as fine-tune, even go as far as if we want to manually do the light mapping and what have you, or clean up the geometry. I'm not going to be that's probably a topic for another later discussion. Is the topology in Casa is not bad. It's the edge looping is almost completed. Ideally, what we would want is complete edge loops, up and down, vertical, horizontal, across. But that's something for a different discussion. Okay, so we're just trying to cover as much as possible to create the idea of the need for an asset source control from whatever application that you're using. So if you're using Blender, you're probably going to have different scene management requirements to keep something this large, manageable, and flowing nicely over into Unreal 4, so that you can identify objects within the space, within the map, that you can go in. Well, there's something wrong with this roof. Click, clean it up, export it as a separate in-place edit, then go and correct your using your block file to update that as to those corrections. So eventually, what happens is everything is replaced. Understandable, a bit confusing. It really does. You really have to get in there and get hands-on to actually get the rhythm, the sense, and once you get the hang of it, it's super fast. Okay, so now let's talk a little bit about materials. Materials. This is where I had a fair amount of problems with the UDK. You bring a material in, a texture in, you create it as a material, you apply it, boom, it works. Unreal 4 is different. It uses it's more of a it's hard to describe. It's more of a shader controlled control than it is a material type. This doesn't even really jive with how materials are maintained and handled in 3ds Max as to applying different materials and sub shader effects to create the type of materials you want. So if you're creating a material, say for example, that is metallic, there are certain requirements in 3ds Max as to materials plus sub-materials to make that look like a metallic surface. So it's materials in 3ds Max is a sub-skill onto itself. Let's just put it that way. Very difficult. Unreal 4 tries to make it easier by bringing those sublayers up to the surface as to being apparent as to relevance. In other words, what actually makes up a material and what should be applied as far as lighting solutions goes. So as you can see, we have a simple diffused material without this metallic. If we disc break that, and without this roughness, the first time you bring your conversion over into with materials intact, it's going to look terrible. It's going to look blowed out and fuzzy and not how it should look as a diffused material. So that's because there's no further information besides it's pulling it. What Unreal 4 is doing is it's just pulling out the color information. That's why it's called base color. So it's not really a diffuse material until you add a metallic, at least a metallic and a roughness value, even if those are set to more or less 0. So metallic set to 0 is, of course, means that this is not a metal surface, but if we create it to 1, then you can see that there's be a little bit more of a shininess depending upon the roughness. So these two main values here need to be, you need at least a metallic and a roughness. Metallic set to 0, roughness set to 1, and then that is now a simple diffused material without any other bells and whistles attached to it. If you're familiar with GDK, it's the same idea. Before you add a shader to it, this is the result that you'll have, just so that we're sure about that. Material wise, there are lighting options. This is something to be taken to be aware of, particularly if you're going to be using opacity type masked materials to create object surfaces, which shouldn't be any you should toss that idea out the window, and then replace that in favor of actual geometry. There's no need to do the old fake the object with a mask trick anymore. Now what we have available to us here, of course, is different types of masking additives and translucents depending on the type of object that you're working on. If you're working with a cloth, then you might want to have a little bit more translucency to it. Masks, of course, you should be familiar enough with that I really don't have to go over it. They also have different shading models. Now, shading models is different than once again than what it is in 3ds Max, where you would have to do a map, a sub shading model. It's obviously it's at the root level about what type of materials you're going to be using. So you have a subsurface. This is actually good for doing. A lot of people have been using subsurface lighting for doing foliage to get that bottom end. There's a two-sided foliage feature into it. This is oh boy, this is hit and miss. Okay, sometimes you can get some really good results out of it. Other times I find that just sticking with the subsurface cheat is works just as well. So this is something that you're going to have a bit of a fun time to work with. Now this is applied to mostly to things like trees and stuff like that. And of course, here's your two-sided selection. Now I'm kind of mentioning these options here because obviously this is what you're going to want to use to be able to establish your first, let's say your first conversion, so to speak. So you can get this in 4 hours. So if we hit play now, I think we just run through test, run around, and we just kind of look at some of the different areas here. We can see that we have some geometry missing. This is the kind of thing you would probably want to look for. This probably was either a model or the material or texture was applied to some sort of clipping brush that was I excluded as part of the import-export, and you can see that we've got some rotation, needs to be correction down here, but more or less happy. The archway here, we can beef that up a bit, make that look a little bit more like an archway, but more or less happy with the overall speed. And as you can see, as I mentioned before, frame rate around right there. Things go bump in the night when you're working in the editor, so don't rely on that as to be an accurate number. Now, if you want an accurate number, just to show it off, let's see, can I spell? Yes, I can. Okay, this is the going on, so what's happening and occurring in our scene, and as you can see that the average, you can see that down at the bottom, I haven't fully, to be honest, I have not fully figured out what all these numbers mean. Well, I got to kind of go through the documentation, but the things that stand out are anything relating to draw calls. You look under the kind of mesh draw calls, 87. Is that for real? Are we actually looking at the number of draw calls? The happy safe spot is a max of 1,000. So you can see that certainly that our max draw calls are significantly lower. Now, touch on one more thing. What's going to happen here is the textures actually turned out a lot better than I originally thought it would. I'm extremely happy with the conversion, and would be more than happy just to leave it alone and leave it as is. However, we can do some fine tuning as part of our performance endeavors by converting all these over to which will be covered to first of all, the main materials like the walls and that you see. There's maybe a couple, half a dozen or so main textures, which are 256 by 256. I might go on to CD textures and find its mate and up it to say at least 512 by 512. As that, what I plan on thinking of doing as I try and see if it's going to work is, first of all, is to convert all the major wall surfaces over to a texture atlas, which means that all these half a dozen textures and materials that are on, like this wall here and this wall here, are all contained onto a single texture, which will drop the draw calls down even lower. So it's only rendering one texture. Just instead of if we look down here, when we export it, there is a lot of materials that were exported as part of the main conversion. That's the thing about GDK is each surface has almost like its own individual materials and textures. So we have like 110 or something like that, which we can bring that down to maybe about three texture atlases, and that would significantly add a performance boost. But more than that, I have some. I bought some software recently that will allow me to convert this over to a PBR substance type of material. So the hit on the material will give us a high quality material. This will hopefully brick will look like brick without adding in any kind of performance a hit, just because it's a higher detailed material. It's the best way to put it is we've discovered make this all possible is Unreal 4 does not add, unlike IdTech 3 FS Tech 1, does not add an inherent performance loss as far as gameplay goes. So it's finally nice to let Epic deal with that end of making sure that the engine performance is up there. So if it starts to bottleneck or whatever, instead of us having to take on the effort of trying to correct the problem, somebody's got a little bit of a performance issue, I'm not getting like my full frame rates or whatever out of it. But you could just go wander over to Epic and say, hey, can you fix this? So anyways, that's hopefully under an hour. But once again, if you have any questions about this process, this is as I mentioned, this is what our intention is as far as Casa goes. We have no control over third parties, so if they want to do like vertical gameplay, what have you, or fancy dancy high detailed environments, I mean, there's room in our world for that kind of stuff, but as delivered, we want to make sure that we have a continuity between the original versus the new and improved. So I really don't see it. The stuff that's available now is just good. It's just too good to just disregard it to waste paper basket and walk away from it. So anything else I need to add? I think I more or less covered everything and anything in one go. So I guess I'll leave it at that. And as I mentioned, I'm going to be moving. This is going to be mirrored over onto our official channel, as well as to give you guys a heads up that the good stuff is now going to be moved over to our official premises, so to speak. So anyways, till next time, see ya.